Hi everybody, welcome to the video and welcome to calculus. This is the first video that's going to be in a long line of videos walking through a Calculus 1 semester. And so check out my channel, check out a lot of the videos that are going to be posted after this. We're just going to go ahead and jump right in here today and look at what is calculus and what are we going to be talking about this semester. So one of the main ideas in calculus is talking about speeds, or another phrase that you might know that sounds a little more mathematical that talks about speeds is the phrase rate of change. And so for us, or at least in this video, we're going to talk about two different kinds of rates of change, or two different kinds of speeds, and we're going to talk about something called an average speed, or think about an average rate of change, which is a phrase you should have heard before. And we're also going to talk about something called an instantaneous rate of change, or an instantaneous speed. And this might be something you haven't talked about before in past classes, and that's okay. Because in this class in calculus, we are going to focus a lot more as a whole on an instantaneous speed, or an instantaneous rate of change. But to introduce the instantaneous rate of change, I want to talk about an average speed, or an average rate of change, and kind of connect what you've seen in past classes with what you're going to see in this class. So let's take a look at an example first of all. And let's suppose that you are driving. Let's kind of just come up with a real world scenario for a second. And let's suppose that you're driving in your car, you're going and not just a freeway, but how about a toll road? So you're driving down a toll road, and the idea here is that I'm going to go ahead and give ourselves a graph and kind of graph where we are at a specific point in time. And so time is going to be like our x-axis here. And for our y-axis, I'm going to use p for position to kind of say where are you at a certain point in time. Okay, so let's think about this a second. You're driving down a toll road, and if you're like a lot of the states in the United States, you might have something on your car where there's a sensor, and there's some kind of video that can detect when do you go under the camera, and then down the road there's another camera, and it'll kind of say, all right, you traveled from point A to point B, and it will know how much to charge your account. Okay. You may be familiar with what I'm talking about, but the idea is, let's say you're right here, you're driving, and then later on down the road, you are somewhere over here because time is going on, and so you've moved on your x-axis, and then you're further along down the road. So your position is, let me write out position because we don't use P a lot, but our position has changed, and so down the road, you're further down the road. And so you could think about when we talk about something called an average rate of change, which again is something that you should have seen before in past classes. You know this by a different word, and this is something that you should be very familiar with. You know this by the word slope. And so if I were to give you just kind of a past example from a past class, and I said something like, if you knew that the coordinates of these 2 points, could you find the slope between these 2 points? And I tell you what, if you're going into calculus, I hope you better say that the answer is yes, I can find the slope between those 2 points. You might remember that the slope has some kind of a formula with it, y2 minus y1 over x2 minus x1. And you'd say, great, if I know the x coordinate and y coordinate of both of those 2 points, I could find the slope of the line that connects those two. Okay, and so I'm going to give you some points here. I tell you what, let's go ahead and I'm going to start out with, let's just say you're just for the first time jumping on the road, and so you're actually starting out on the x, or at the origin here. And then how about something like after about, let's say, 6 minutes, here we're going to put t in minutes. It doesn't have to be in minutes. It could be hours. That's a pretty common thing for us. After 6 minutes, you've gone 5 miles. So the position is going to be talking about how many miles have you driven down the road. And so you have some kind of a point right up here. And if I were to say, could you find the average rate of change between those 2 points? Again, I hope your answer is yes, I could. You just take y2 minus y1 over x2 minus x1. Great, no problems there. Okay, but here's the problem with that. If you're driving down the road, I don't know anybody, I don't do this myself, it's really hard to drive exactly the same speed the same exact time. So when we're talking about a speed here, by the way, a speed or an average rate of change, or really any kind of a rate of change, that's going to be true for an instantaneous rate of change down the road later on as well. When we measure speed and we talk about the units for speed, it is always going to be talking about a distance divided by a time. So miles per hour, miles is a distance, hours is time. It's not as common, but you could talk about miles per minute. That's fine. That's kind of the example that I have laid out here. In physics, you often have problems where you're talking about feet per second. It's just some kind of a distance divided by some kind of a time. That's all that's saying. So when you're finding the slope of the line between these 2 points, you're actually finding a speed which uses distance divided by time. Okay, so when I talk about at a specific point in time, maybe you're not quite 6 minutes down the road, maybe you're only 2 minutes down the road, you still have a specific speed. Okay, and that's going to be the idea of what we're going to talk about as an instantaneous rate of change, of like, what is your speed right at that time? Okay, but an average rate of change is talking about from one point, we'll call it point A, to point B, where is, or what is your kind of change of your rate of change from a starting point to an ending point. But again, here's what I said earlier, is the problem with that is that nobody really drives exactly the same speed the whole way. In fact, if you're driving down the road, it's probably more likely that your speed looks something like this, where you're kind of going faster and then you kind of slow down and then you're going faster and then you kind of slow down. And the idea is that eventually you still end up at that same place, that same position at the same time, but your kind of travel graph here does not look like a straight line. It probably speeds up and slows down and has a little bit more curve to it at different times. Okay, so this is the idea of an average rate of change. When we talk about an average rate of change, we can still say, hey, regardless of how fast you are going at a certain point in time there, okay, or at a different point in time, or at a different point in time, or pick any point in this graph, regardless of how fast you're moving at a specific instance in time, from the time when you started that point A to end point B, you can figure out your average rate of change. Okay, I don't know if you did that, but you could actually do that in this example. We know that speed is distance divided by time, but we know specifically what your 2 points are. So pretend like you're back in an algebra class. You could go find your average rate of change. You could go find your slope. That would be, let's see, we're doing y's on top, so 5 minus 0, and then divided by 6 minus 0. Keep in mind that we are talking about miles per minute as our units. This is 5 divided by 6. And so if you take your 5 divided by 6, that's how many miles per minute you're going. If you wanted to have that in terms of hours, because this is miles per minute, if you wanted to convert this to miles per hour, you could multiply by 60 minutes, and then the minutes will cancel on top and bottom, divided by 1 hour, and let's see, you cancel the 6 and the 60, you get 10. So you were actually going 50 miles per hour, okay, over that stretch. But again, something to keep in mind is that doesn't mean you're going 50 miles an hour at exactly every point in there. It just means your average speed from the time you started to the time that you ended was 50 miles an hour, okay? So here's a question for you. Suppose that the speed limit of the road that you're on is 45 miles an hour, okay? And from the time when you started, you got measured by a camera, and from the time you ended, the camera knows exactly what time you went that certain distance to the next camera. It says your average speed was 50 miles an hour. Here's a question for you to consider. Could the cops give you a ticket? Okay, and the answer there would be yes. If they really cared about you going 5 miles an hour over the speed limit, they could. Now, does that mean you are going 45 miles an hour, or I should say, does that mean you're going 50 miles an hour the whole entire time? No. In fact, you could have been going 60 miles an hour some of the time at really faster stretches, and then other stretches you could have been going slower and been going more like 40 miles an hour. But your average rate of change as a whole is based on what time you started and what time you ended. Okay, so this is an average rate of change. You can think average rate of change because it uses 2 points. to calculate a slope or to calculate the difference in the x's and the difference in the y's and uses that. All right, so here's a question to consider. What if the speed limit is 55 miles an hour? What if the speed limit is 55 miles an hour on that stretch? Does that mean that you were never speeding? Okay, and hopefully you're thinking about kind of the different possibilities there, and the answer there would be no. Like, you could have been speeding at certain times. It just means your average speed as a whole was not more than 55 miles an hour. Here's about that situation. Like, what if your speed did something, or your graph looked something like this? So here's a different graph that starts you at 0, 0, that ends you at, what was it, 6 and 5 up here. And maybe you still end up at that point, but your graph maybe looked like this. Right? So in other words, you sped up really quickly to get to where you were going, and then you slowed way down. And if you think about the slope as being like a speed, we can think about kind of the slope of like a line right there. That's not a very high slope compared to the slope of a line that goes like that. So at the beginning you were going really fast, and then you slowed way down. So if the speed limit is 55 miles an hour, does that mean you were never speeding? No, it doesn't. You could have been speeding, but your average speed is not above 55 miles an hour. Okay. By the way, this is used in, I've been told, I haven't experienced this myself, but I've been told that places in Europe actually use this to give out speeding tickets on toll roads by calculating your average rate of change, your average speed. And if your average speed is too high, then they'll actually give you a ticket even if you don't get pulled over by the cops. Okay, so I'm not telling you how to get out of a ticket, but a thought is, if you're going really, really fast, one way you can take down your average speed is to slow way down, and then your average speed won't actually be as high. Anyways, this isn't about getting tickets. It's about, or isn't about telling you how to get out of a ticket. It's more telling you about the math behind speeds and rates of change.